So we thought, well, Johannes, you should do it because you're going to get a change in voice. It might get a little bit dull to listen to me all the time. So maybe we can do some switching over or something, do some commentary like between, or I mean to kick it up a notch. I thought of doing a joke speaking like Damien in French, but I thought it is not appropriate. So you did not hear that. That is not what happened. We have Hannes over here. He's thinking really.
Try Japanese instead. That's much more interesting.
That is, yeah, that I would fail at, and they'll be like, where is Hannes? There, yes, he's there, yeah. He looks very handsome. And then Damien, who really wished to be here, because he's a great guy, and kind of had done a lot of this work and would be able to give a great talk. The good thing about Damien, so in my slides, it's kind of a little bit wishy-washy, like all kind of concept-ish. The good thing about Damien is that the way he makes his slides is that it's to the point, he's technical. It's to nothing to come at. So his work with Damien has got a zonefs, and then Ting, which unfortunately could also not be here because travel restriction. She has done a lot of great work in LevelDB. And they kind of mash those two together, which is really awesome. All right, so as Damien, yes, here's the background. We're going to talk about zone block devices. I've seen most of you, there's not that many of you that kind of came in after it, so we're going to skip over that a little bit and win a couple of minutes. Have the Linux support, then we get into zonefs, and we go into the nitty-gritty details of how it works, and then Ting's work on LevelDB and future work. Cool. So another way to look at these zone block devices is that, and I kind of thought, hey, let's go steal this because it's a good visual representation that we have. Where is it? For SMR hard drives, SAC and CPC, all good. Zone 0, then there, and within the zone, you write sequentially. This is a great picture that I should probably have used. And what he points out here, like, well, this is for SMR, and then for zone namespaces, there's no conventional zones at this point being standardized, but might come in the future, but the way you would do it is as a conventional namespace instead. So that's not really a need for it. At least that's the argument for it, so we didn't spend time on it in the standard group. All right. So POSIX file system. So the POSIX, the POSIX interface is that we have, where you work with files. The way you've been working up till now with zone block devices has been through IOCTLs and just being very careful how you do read and writes using direct IO. And it works. When you've done it a couple of times, you get quite good at it. But when let's see, what can we do is kind of like to make it better. And that's where zonefs comes in. And whenever Damien, can we do some other work? No, I'm in zonefs, I'm building it. So he's been really spending a lot of time on this the last couple of months. It's awesome. And the idea is that we want to simplify the raw block device access and the management of these zones through this file system API. All right, so here's an overview of zonefs. The ground idea is that each zone is a file. And they're exposed as regular files. So you have what's called sequential zones and conventional zones. And the file size is kind of the write pointer within the drive, and so they kind of match. And the way we kind of get this information is that we go ask the drive upon the start of when we mount the file system, hey, give me the zones. And we kind of get up the file size and so on. So it's kind of, you can call it the kind of co-designed file system. Yeah, it's modern these days. Well, it's been for ages, but yeah. So, and then you have these conventional zones, which conventional zones is just random write zones. You can write whatever. So in SMR hard drives, it's 256 meg, and you can just wherever you want to do. It's pretty straightforward, where you have a zone number per zone type and so on. We're talking about, not in this version that's upstream now, we kind of have dynamic allocation. So you're going to create a file, and then you kind of do the dynamic mapping behind the scene, which is cool if you have multiple applications that are using the same device, then suddenly you don't need to coordinate between those, who gets what. You can create a file and you get it up, but that's kind of 2BD kind of work that we are for the future. The way it's exposed is that we have this file tree where you have conventional zones, Z and V, and sequential zones, sequential write required or write preferred zones. As sequential write required are those zones where you have to write sequentially. Sequential write preferred zones is like, I'll prefer if you write sequentially, but if you don't do it, it's okay, doesn't matter. Which is actually, it's might something we should also, this is not something that's been standardized in CNS now, but it might actually make sense because there's talk in the industry around building an NVMe hard drive. So, and since NVMe hard drive will probably expose SMR, probably makes sense to build that in so that kind of device can be exposed appropriately. Right, so in the bottom here, there's two ways to kind of represent the conventional zones. There's no zone aggregation and there's aggregated conventional zones. So you have like, the next slide, like 500 zones that are conventional. You can either expose them one file for each, or you can kind of say, oh, put them all together, aggregate them, and then you have one. I'll get back to why that is an awesome idea. And the kind of thing is, like for this file system is that, well, so how you can kind of select when you mount the file system is if you want to do the conventional zone aggregation on or off. You can do the default use ID, group ID, and access permissions. There is kind of mount options around like how you want to mount it, remount, read-only, zone read offline, and so on. And kind of like how they behave over here. So like the file size, you can see how it behaves and so on. So these slides are going to go online, so this is going to be a good list for you to kind of, when you want to look into zonefs and how their behavior is. So that's kind of a really nice mapping table to have for the future when you kind of look into using zonefs. The thing is, zonefs is not your regular file system. It's, well, you still have this requirement of writing sequentially. So it's not all, you still have to have these zone block device compliant applications. So these applications still have to write sequential within. Fine, you can do that. And there's all kind of, for the zonefs now, that's kind of, it's bare minimum, works, everything is great. In the future, you can have cases where, well, direct IO write, well, we can make it buffered and so on. There's a lot of things we can do here, which is really interesting. So that's kind of upcoming and for the future. All right, so how does it look? So for this particular 15 terabyte SMR drive, we have 524 conventional zones and 55,000 sequential zones-ish. And you have like make zonefs, and you point it to the drive, and you mount it, it's all good, and you list it, and you have those two directories we talked about before, and how many number of files, that's how many zones there are in each of each type. And you go in the library, into the directories, and you see, hey, the conventional is from 0 to 522. There's missing one zone, right? To be 523. There we go, perfect. And that's why Johannes also needs to be in this. There we go, and which is on the next slide, yes, exactly. And then you have the sequential write required zones down at the bottom. And with aggregated, then there's just one file, and you have the full capacity of all the random write zones there, in the conventional zones. Cool. All right, so now here's a comparison between how you do it as like in the old days with IOCTLs and how you do it with zonefs. So if you have a raw block device, you have block number of zones and block report zones, IOCTLs. And then you have this struct block zone data structure, which contains all the information about the zone. And the cool part is that this is how you kind of did it, where, hey, you go in, how many zones are there, you allocate how many, the buffer you need, and then you do block report zone, and then you go in, iterate, and really go, it goes as the drive, comes back with information, and then you do your kind of in the data structure you want. For zonefs, you go in and go for the directory, and then you just have these file names. So it kind of takes care of that for you. So it's kind of another, you do the same thing, but you do it in two different ways, one through the POSIX interface, another through the IOCTL interface. Then there's how you're kind of going to write to it. So normally that's where you kind of be in a line, like the P write, you align it perfectly. Don't you do anything wrong, and then it will not screw you up. That's one way, that works pretty well. And then, but you can corrupt, you can kind of write into another zone. There's no protection here. If the zonefs case, what it protects you is from shooting yourself in the foot and kind of protects you from writing into another zone. So that's very powerful and a good protection. And I know that is a lot of things when we did an open channel, we kept doing this mistake over and over and over again. It was kind of like, did you? Yeah, I did. It came up a couple of times. And obviously, you have the zone management command, zone reset, and zone finish. And the way they map into, you have the IOCTL for the block reset and the block finish zone. You send it down. And for over in the zonefs, you do truncate to reset a zone. And to finish a zone, you kind of just truncate and then up to the size. Works fine. So that's pretty cool. So that's kind of another way to represent it and kind of what zonefs allows. Cool. So Ting Yao, her work on LevelDB, where she's modified LevelDB to support zones. And her work is public. It's data paper at FAST? FAST, yeah, okay. And where she kind of added support here, and it's like used with SMR hard drives and so on. And what she did here, like she came on board at WD as an intern, and then, well, we have these nice ZNS drives. You should try it out. That is a good idea. All right. So she went ahead and do that. So we made a comparison between ext4, this Ted here is the author of, and ButterFS. And we have the ButterFS zoned, which is now Hero's work, and then the raw block device and zonefs. Then 16-byte keys and 4 kilobyte values. And then we do DB bends, which is a benchmark within LevelDB. We do fill random, read sequential, fill sequential, read sequential, fill sequential, and then two times read sequential. I'll show why that's interesting. And then we average over 5 runs. All right. So what we kind of see is that when we fill random and then read sequential, is that the write performance is much higher. So that's one of the things, right? So we have good write performance, and ext4 is there. But I mean, the reason we get high write performance is we do direct write. We don't do what a real file system actually does. So take it with a grain of salt. This is not like, yeah, you're doing actually direct write. So this is how you should look at it. And one of the things we see here now when we do the read sequential is that since we do direct I/O, we don't get through the page cache. So when we read it in again the first time, hey, we cache it. And then the second time, performance is good. All good. So that's the same kind of story we saw for both of them. So there's some benefits to be had here. In RocksDB, there is actually a user space buffer manager. So for RocksDB, this case about read sequential 2, 1 and 2 is actually, you would have a best case where it actually be cast already. I don't know if that's true for LevelDB, but I'm sure someone here in the audience can correct me if that does exist today. Right, so Linux pulled it in, and right last minute before the 5.6 release candidate 1 came out, so like, I think like 15 minutes before Damien got it, yeah, I pulled it in, fine, awesome. So you find it under the file system menu, and you gotta make sure you have this block dev zoned part. So if any of you have this Red Hat, this is, now there's even more reason to enable this bit by default, and thank you, Susan, for having it already enabled. I know Damien is all excited about that. And normally you would put test into XFS tests. Right now Damien is not planning to have support for that because there's so few similarities between normal POSIX file systems, which does real work, whereas zonefs kind of maps it into these zones. So therefore he made a test suite which is provided with these zonefs tools, which is also where you want to find make zone fs. Right, last slide. So there's, we want to do better handling on IOCB no wait for asynchronous IOs. You want to have better support for the zone explicit open close, integrate NVMe Zoned append, yes. And that also means how do we make it for SAC and CBC, for SAS and SATA driver in the kernel, that's good. Might even extend it to SAC and CBC. Read after write, performance improvements, stuff there to do. Hans is working on RocksDB, and kind of due diligence, get the work done, artisan kernel, let's continuously improve it and make it useful for people that are kind of building applications for zone block devices. Yeah, thanks a lot, everyone. And Johannes, you'll just, any hard questions, you'll just come in. Here we go.